This is not a benchmark victory lap. This is a real patch published from a Kimi K3 DeepSWE trial. It faced 85 feature checks and 6 regression checks, all 91 passed. The patch is 46 kilobytes, the repository is pinned, and the verifier output is public. That is enough evidence to pay attention. It is not enough to declare the coding problem solved. So instead of reading a score aloud over glowing rectangles, we opened the artifact. First, the wider result. On DataCurve's DeepSWE version 1.1 table checked July 22, 2026, Kimi K3 in its max compute preset sits at 69% pass at 1 with a 5-point uncertainty band. The evaluation covers 113 tasks, 91 repositories, 5 languages, and runs through DeepSWE agent. Average cost is $4.65 per task, with roughly 81,000 output tokens and 98 steps. That is a serious result. It is also a harness-specific snapshot, not a law of nature. Our proof task lives in TS-Pattern, a TypeScript pattern matching library. The requests sound small, add match each. But it has to process every matching element across arrays, sets, and maps, preserve useful type narrowing, work with the library's existing matcher protocol, reach the public exports, and keep old behavior intact. A feature can look perfect in a JavaScript demo and still fail because the inferred TypeScript result is wrong. That makes this a better test than asking an agent to center a div and then awarding it tenure. Here is the published model patch. It adds the match, each implementation, new generic result types, public exports, and the test surface needed by the benchmark. More importantly, it follows the repository's existing abstractions instead of building an unrelated side door. The trajectory shows K3 reading matcher internals, working through collection behavior, and revising type definitions. The artifact is 46,528 bytes. Line count alone proves nothing, but the structure is inspectable. Runtime behavior, type behavior, integration, and tests are all present. Then comes the deliberately unglamorous part. The beta runner clones the public repository, checks out base commit F66FC06, applies the exact frozen patch, installs the pinned project dependencies, and runs the available verifier commands. We retain the patch hash, command lines, standard output, standard error, exit codes, and test counts. If this machine cannot reproduce the run, the screen says blocked. It never quietly promotes DataCurve's published pass into our local pass. A green terminal is useful only when you know which terminal, which commit, and which command produced it. At this point, Benchmark Brain sees a green checkmark and begins composing a thread titled, quote, "Software engineers are finished." Benchmark Brain is very efficient because it skips the inspection step. We will not. One successful final state tells us where the run landed. The trajectory tells us how it got there, how much context it consumed, and whether the apparent one-shot genius was actually 37 tool calls wearing a trench coat. The passing trajectory took 37 steps, produced 44,732 output tokens, reached a peak context of 68,345 tokens, and cost about $1.23. The agent repeatedly inspected files, edited the implementation, ran tests, read failures, and revised the types. That loop is not a criticism. It is what capable coding agents actually do, but it changes how we evaluate them. A team should measure successful delivery, total attempts, review burden, and cost across the whole task, not just whether the final diff photographs well. And the public artifacts include misses. On the async autocomplete task, this selected K3 trial kept all 643 regression checks green, but missed 2 new cases that expected an error message after a failed fetch. The binary reward was 0. One miss does not invalidate a 69% table result, just as one win does not guarantee your migration. It shows why averages need texture. In production, the failed task is not diluted into a pleasing leaderboard percentage. It is the task blocking release while someone explains to the incident channel that the model was excellent on a different repository. What is K3 itself? Moonshot describes a 2.8 trillion parameter model with a 1 million token context window, native vision, Kimi delta attention, and attention residuals. Kimi code exposes the model as Kimi K3. Those are official product and architecture claims from the model maker. This patch does not independently prove them. At the time of our check, the weights were promised for July 27th and the technical report was still forthcoming. Pricing also makes the output-heavy agent loop worth watching. Official rates list $15 per million output tokens. The verdict is neither miracle nor shrug. Kimi K3 has a strong current DeepSWE signal, and this exact trial contains a substantial patch that passes the published verifier. That earns it a serious pilot on real work. It does not earn blind merge access. Give it 3 representative tasks from your own repositories. Pin the environment. Hold out tests the agent cannot edit. Review the diff. Track retries, total tokens, wall time, and human cleanup. Then compare the whole delivery against your current model. The most valuable model is not the one with the loudest launch slide. It is the one whose evidence survives contact with your codebase.